Hi everyone, in this video I want to talk about related tests. What's the method to do a related test and give you an example. Related test. Methods and example. So in our previous video, I talked about if you know there's a bias, then you should not use related test. But then knowing how to do a related test is very important, right? Sometimes if you kind of know there's no bias, and then a related test can speed up the process. Okay, so let me go ahead with an example. So Michelle wants to see if coffee can affect heart rates, right? So whether coffee can affect heart rates. The way she's going to do it is she's going to take a sample of 6 people. Record their heart rates, before and after drinking coffee. Okay, before and after drinking coffee. Okay, very good. And the next step is to calculate the test statistics, find the critical value, and make conclusions based on the data we have. Okay, so let me write out. What we want to do is we want to calculate test statistics, state the critical value, and make conclusion, right? Conclusion. So the process is pretty similar than what we had before. Let's assume we want to do alpha equals to 0.05, so 5% significance level with two-sided test. Okay, we want to do this. Okay, now let's get started. First, I want to point out is that in this case, even though we have only one set of sample, we're only 6 people, but we are looking at 2 populations. Okay. First one I want to talk about is we are testing, or we have 2 populations. The first population is the population before drinking coffee. Population before coffee, and the other population is population after coffee. Okay, so in fact we have 2 populations that we're looking at, before and after coffee. Next, let's just state null hypothesis. Okay, let's state the null hypothesis. State null hypothesis. Okay, and the null hypothesis is before coffee population should equals to after coffee population, which means that there's no difference. And then the alternative is that they're different, so coffee has effects. So, okay. And next, I want to point out the fact that usually our sigma, or the population standard deviation, is not given. Okay, so usually our sigma is not given, So we will have to do t-test. Do t-test. Okay, so we have to do t-test. Okay, so let's just start solving this question. Okay. Okay, so solving it. Okay, so solving it, let's point out one observation, is that if we look at our null hypothesis and alternative mu b equals to mu a, the alternative is mu b not equals to mu a. Okay, so the hypotheses here are different than what we had before. What we had before is the population mean equals to a number. But here we have two population means here, right? So the way we deal with this is try to name a new variable. Then we can set that new variable equals to numbers that we want to test. Okay. We want to do this, create new variable. Okay. And let's define this mu d, right? The difference between the two. Define as mu b equals to mu a. Okay. And if we do this transformation or this creation, what we get is the null hypothesis is mu d equals to 0, right? So if they're the same, subtract them, it equals to 0. And then the alternative hypothesis is mu d not equals 0. That means they're not the same. Okay, so we're doing this. Okay, so now we're working with this mu d here. We'll have to create a new variable for our sample, which is the sample mean d, or x bar d. Okay. And let me show you how we do this. Okay, so let's say the data we have. Okay, so we have 6 people, and we have the no coffee group. Well, before coffee. Right? Let me say before coffee, and after coffee, and our difference, right? So let's just say XD difference. 79. 71, 84, 66, 73, 76, and here 84, 78, 87, 75, 79, 82. Okay, so each pair, if one person, right? Person 1, person 2, person 3, person 4, person 5, person 6. Before drinking coffee, heart rates. After drinking coffee, heart rates. And with this, we can subtract them, right? So let's subtract the 2, we get minus 5, minus 7, minus 3, minus 9, minus 6, and minus 6. Okay, and let's sum these up and divide by 6, right? If we sum these up and divide by 6, we'll get our sample difference mean. So we have our sample difference mean. Okay, so sample difference mean, what we get if we sum up these 6 numbers, what we get is x difference bar equals to minus 6. Okay, so that's average of xd. Good. And now we're ready to calculate our test statistics. Now, calculate our test statistics, our test stats is equals to x d bar minus mu h naught d, right? So which means that it's the null hypothesis under, it's the mean under the null hypothesis and divided by d hat square root n. Okay, so this one is a standard deviation, estimated standard deviation of the difference. And let me just make sure it's clear. As we estimate sigma d with sigma d hat, right? So we don't know the population, so we have to estimate it. Now let's estimate it, sigma d hat. Let's write out the numbers. So I'm going to do it with a table here. Minus 5, minus 7, minus 3, minus 9, minus 6, and minus 6. And now to get the value xd minus xd bar, right? So again, this is minus 6. We got 1, minus 1, 3, minus 3, 0, and 0, right? So I'm using these numbers, subtract negative 6. And then I want to square them. Bar squared them, we get 119900, and I'm going to sum them up because we'll need this number, and they sum up to 20. Okay, now we're ready to solve for sigma d hat. Okay, so formula for sigma d hat equals to square root summation xd minus xd bar square divided by n minus 1, and this is the formula. And we got this part here, right? So this part, just sum of these 6 numbers equals to 20. So this equals to square root of 20 divided by 5. We have 6 people, n minus 1 is 6 minus 1, and this will give us square root of 4 equals to 2. Okay, so our sigma d hat is 2. So we're ready to go back to our test statistics. So test stats, xd bar minus mu d divided by sigma d hat. Okay, over square root of n. So that's equals to minus 6 minus 0 over 2 divided by square root of 6. That's equals to minus 7.3484. This is our test statistics here. Okay, once we test statistics, the next step is to find the critical value that we can compare to. Okay, find critical value. So find critical value, again we're doing the t-test here, okay? Because we don't know the population standard deviation, so we're doing the t-test. And our degree of freedom equals to n minus 1, 6 minus 1 equals to 5. 5, and then with our t-table, degree of freedom equals to 5, and the alpha equals to 0.05. Then our critical value equals to minus 2.571, or in absolute value goes to 2.571. Okay, now we're ready to do comparison. Okay, so our test stats equals to, in absolute value, 7.3484, and our critical value, absolute value equals to 2.571. Okay, and since our test stats is greater than our critical value in absolute value, the decision is that we'll reject the null hypothesis. Okay, reject the null hypothesis, which means that say the null is d equals to 0, the alternative is d not equal to 0. So we're going to reject this one. Then what's the conclusion? So by rejecting the null hypothesis, we're saying that heart rates are likely to be different after or by drinking coffee. By drinking coffee. Okay, perfect. And this is how you would use your data to do a reader test. Thank you for watching. I'll see you in the next video.